Running Code Assistance AI locally means operating under strict hardware constraints. We are dealing with small parameter models, specifically in the 0.5 billion to 7 billion parameter range. These are neural networks small enough to run on consumer-grade machines without relying on external servers. To give these constrained models memory, developers typically use Standard Retrieval Augmented Generation, or RAG. This architecture attempts to improve AI responses by fetching external documents and adding them to the user's prompt. It treats context as a flat, probabilistic sliding window where raw text is continuously funneled in until the memory limit fractures. Small models break down when forced to process these unweighted, compressed text blobs. They lose track of exact file names, misinterpret code hierarchy, and begin inventing non-existent syntax. This causes direct structural hallucinations. Probabilistic context stuffing fails on local hardware because the model lacks the parameter count to independently weigh the reality of the data it is reading. If you feed it a flat string of text, it treats a highly specific code snippet and a vague paragraph from a README file with the exact same level of authority. To solve this, the CodeMonkey architecture completely discards the sliding context window. It replaces it with the grounded bag interrogation model. Instead of flattening codebase files into a single string of text, this system models context as an interrogatable evidence substrate. A substrate is an underlying layer where specific processes occur. Here, it is a structured mathematical graph where data is actively queried rather than passively ingested. This graph operates on a strict epistemological rule. Every piece of retrieved data must defend its own weight and validity based on its structural position, rather than relying on the LLM to guess its importance. We can observe this mechanism by tracking a single complex user query. What architecture change follows from this file as it moves step by step through the system's 7-stage interrogation protocol. Treating context as a dimensional graph shifts the local AI's role. It stops acting as a passive reader summarizing a text blob and operates instead as a deterministic reasoning engine executing a highly constrained search. The protocol begins at stage 0, intent classification. When the user asks about an architectural change, the system parses the query to identify its actual objective, separating the core goal from conversational phrasing. This parsed query does not remain isolated text. It is transformed into a first-class graph object called a prompt node, which is injected directly into the knowledge base alongside the codebase itself. Moving into stage 1, the prompt node induces a bounded task-local subgraph of evidence. Using greedy density algorithms to pack the most relevant information within strict token limits, it locks them into a specific geometric neighborhood called the candidate bag. This candidate bag is not the answer. It is the highly constrained pre-response environment. By isolating this specific cluster, the system narrows the search space to the exact data required to form a factual response. Converting the prompt itself into a physical graph node permanently anchors the reasoning task to its relevant data boundaries. The AI cannot drift because its instructions are tethered directly to the local evidence. Stage 2 executes a critical constraint step before a single token of answer text is drafted. The system injects a provisional response anchor. This is a virtual constraint object placed directly into the candidate bag graph, acting as a structural blueprint for the impending output. The anchor evaluates the user query and locks in specific requirements. It defines a center type, such as relational or semantic, and sets the expected answer type, forcing the impending beta to conform to a pre-approved schematic. Mechanically, the anchor gives the final answer directional shape. It physically prevents the AI from engaging in free-floating synthesis by demanding that all generated text fit the pre-established mold. Establishing an answer-shaped constraint prior to generation limits the autonomy of the language model. The AI must build within the blueprint, preventing the drifting logic common to small parameters. In stage 3, the system interrogates the bag members. Instead of handing the AI raw text, the system extracts the data into strict typed interrogation records across 5 distinct dimensions. The first 3 dimensions define physical reality. Identity establishes what the object is, like a file or symbol name. Structure determines exactly where it lives in the codebase hierarchy. Verbatim extracts the literal text it contains. The remaining 2 dimensions map broader meaning. Semantics summarizes what the file actually does. Relations maps how it connects outward to callers and dependencies. The system applies an intent-to-dimension priority rule. It explicitly refuses to inject all 5 dimensions at equal weight. Because our trace query asks about an architecture change, the system prioritizes relations and semantics. Exact verbatim text is dialed down in weight because the task requires structural mapping rather than line-by-line reading. Extracting typed dimensional records forces the LLM to process distinct categories of evidence. It receives highly sorted logic, completely eliminating the need to blindly summarize a compressed blob of text. Stage 4 applies verification questions. These are non-negotiable grounding guardrails that govern how the model is permitted to interpret the dimensional records. The system enforces a strict hierarchy of truth. Verbatim code and physical file system structure strictly outrank any semantic summarizations provided by the model or the documentation. The absolute rule of identity dictates that if direct identity evidence exists for a file or object, the model must use it. If evidence is missing, the model must state that it is unknown. It is prohibited from inventing a structural substitute. Semantics have strict limitations. Human-written summaries, like readmes or devlogs, are authorized to explain intent, but they are never permitted to override observed structural reality. Prioritizing physical code-based reality over semantic summaries ensures the output remains factual. By dictating the exact authority of the input data, structural hallucinations are removed from the generation process entirely. At stage 5, the constrained local model synthesizes the answer. It generates text using only typed interrogation records, bound entirely by the provisional anchor's blueprint. As the text generates, stage 6 initiates. The system simultaneously constructs a support bag, which is a refined overlap subgraph generated alongside the response. The system maps the exact overlap between the newly generated text and the specific typed records that were utilized to write it. Every drafted sentence is tied directly back to its source data. This support bag explicitly exposes what data truly backs the answer. If the LLM generates a claim that lacks a supporting vector line back to the evidence, that gap is instantly highlighted. The support bag transforms black box text generation into a fully mapped, traceable evidence graph. The system can physically prove where every part of its response originated. Stage 7 executes the response audit. This is the final epistemological check before the architecture proposal reaches the user. The system enforces a response audit form, a strict schema categorizing every single claim. Observed claims are direct verbatim or identity facts. Inferred claims are logical derivations supported by relations. Proposed claims represent new code or architectural changes. The system runs a final support state check. It evaluates the sorted matrix to determine if the answer is sufficiently grounded in the evidence bag. If the proposed changes lack observed and inferred support, the system rejects the draft entirely. By structuring context as a dimensional graph, enforcing constraint blueprints before generation, and running strict categorization audits on the output, the system successfully forces a small local model to operate with the deterministic rigor of a compiler.